My name is Brix Pedersen. I work for PernixData as a system engineer. So I'm doing a lot of work with PernixData, installation, POCs, and helping customers and helping people to learn about what PernixData is doing and how they use PernixData. During this presentation, I will show you some PowerPoints about PernixData, how we can use PernixData to architect the perfect data center from our products, FVP, and our new product called Architect. So I'll do a presentation of both products. And then, of course, I think you need more than PowerPoints. So I'll also do a live demo so you can actually see what this looks like. So it's not like, I think everybody can do a good PowerPoint. Not everybody does it, but everybody should do it. But let's also try to see if the demo lives up to it. And where I want to start with my presentation, that is, look going around in the vendor area. It's kind of like there's so much hatred down there, right? Like, don't do that, don't do that, don't do that, know that, know that, know that. So I just want to change it up. Instead of saying no SAN and no, 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 I will say, I love SAN. I love SAN. And I will make you guys fall in love with your SAN again. Some of you guys maybe already love your SAN, but maybe you lost it, like just with your wife in the beginning. All was perfect, right? And then it's more, it's getting a normal daily life. But with PernixData, I think I can make you guys fall in love with your SAN again. So if not, let me know. So how do we get to this point where we can go fall in love with our SAN again? How do we get to this utopia of this place to go? So what we need to do that is that we need smart storage. We need a smart SAN, something that has application intelligence, and that is something that is virtual machine aware. So it's not just aware of itself, but it's aware of the VMs and the application that runs on this storage array and provides you back with this information. Of course, it needs to be fast. You need low latency, you need high IOPS, you need something that will be fast as it can be. Maybe even faster than Flash. How do you like that? Would you have something that's even faster with Flash? Today, I will give you faster than Flash performance. And of course, it has to come at the right cost. It has to scale with your demand, and it has to come with the right cost for your application and for your infrastructure. So how do we get to this? We talk to PernixData, and we join the session. So this is your opportunity to go home with all of the knowledge you will gather today and take this knowledge into good use. PernixData company. Let me just get a brief hand. How many in this room know of PernixData or have played with it or have downloaded it? Okay, we have some guys. And how many people in this room can like, PernixData, what is that? Okay, we have a few as well. Okay, so just a little bit about the company. The company PernixData, it's almost 4 years old. So it's still a young company, but we've been here like for 4 years. The company was started by some ex-VMware employees, Poojan Kumar and Satyam Vagani. Satyam Vagani was within the first 100 people working for VMware. While he worked for VMware, some of the technologies Satyam made was, for instance, the VMFS file system. Anyone in this room use VMFS? Yeah, I think so. So the guy who made VMFS is the guy who started PernixData. The guy who was the inventor and initial creator of virtual volumes that you now saw in vSphere 6.0, that's a guy who started PernixData. So there's like a strong VMware DNA inside the PernixData company, because basically a lot of the engineers from PernixData have been building and working inside the VM kernel since the beginning. But now they thought, VMware, 15,000 employee company, great products, but we need something, we need some new cool projects. Just like when the DDSXI in the beginning, let's try to go from the beginning, build something new. And that is when they started PernixData company 4 years ago. The way PernixData will, for the first thing, give you application intelligence and VMware awareness in your environment, that is by using our newest product called Architect. The architect product was just released 1 week ago. I will have some PowerPoint, some screenshots, and I will give you an introduction. But this will be even better once we go to the demo, because doing an architect, you don't need screenshots. You need to see this live in action. So we'll do that after the presentation. But architect, what is architect all about? Architect is a tool made for architects. It's a tool made for the people who needs to architect and design and implement a data center and a storage infrastructure. It doesn't matter if this storage infrastructure is hyperconverged, if it's SAN, if it's with PernixData FTP software we're going to talk about. Architect is built to give you the information you need to design storage, because you will now start to design storage from the facts, from what is actually going on from a VM level perspective, and not what is going on from the SAN perspective. So imagine getting VM knowledge and summing all the data up and giving it back. So whenever you need to design your storage or expand it, then you can use the architect software for that. So architect will give us real-time VM and storage analytics. It will also give us predictive design recommendation. So while your storage is running and your data center is dynamic, things will change. So if there is some new things that needs to happen, then the architect software will say you, hey, you have this VM that is doing something bad. Change it. You have this VM that is doing this. Change it. So it's not about just giving you a lot of graphs and things you can think about. It's about giving you data that you can execute on and telling you what you need to execute on. The architect software, it's 100% hardware agnostic. So it doesn't matter what kind of SAN you're running. If it's from EMC, or IBM, or HP, NetApp, Pure Storage, Nimble Storage, it doesn't matter what hardware you're running, because the architect software will run inside the VMware ESXi kernel. And that is how we can see all the I/O and give you back the information. And that means it's for all storage platforms, as long as, of course, that you're running with VMware, because the architect software is installed inside the kernel. What we do with the architect software, that is we take big data into big knowledge. So when we're in the kernel, we see everything that is going on for every virtual machine. So we get so much data. And the difficult thing is not to take this data and present it back to you. The difficult thing is to take this data and present the small amount of data that is meaningful for you as architects and meaningful for you to design and deploy and optimize and run your storage infrastructure. That is what architect is doing, taking from all this data, finding the right data. Some of the stuff we will show you is a small screenshot showing you what is the block size distribution in your environment. So just imagine being able to see not only IOs and latency and all of these key measurements, but also being able to break this down all the way down to block size. So from a VM level, seeing in an easy-to-use graph, what is the block size distribution from our virtual machines. That is something PernixData can do since it's sitting in the kernel. Other thing PernixData will do is it will even let you see your working set sizes for your virtual machine. Because one thing is that you know that you maybe have 20 or 40 or 50 terabyte of data. That's okay. But if you're designing in a hybrid array, or you're designing for FTP, or you're designing auto-tiering in your storage array, you'll be thinking, okay, so how much hot data do I have? Like how many SATA drives do I have? How many SAS drives do I have? How many flash drives do I have in my storage array? And then your storage vendor will say, well, you need 10% flash from capacity. And sometimes it's true, but most time it's not. Because it's just a thumb rule. They just think 10% is the magic number. But why not get the real number? Why not let the architect tell you for every VM in your environment and sum it up? This is your active working set size. Now you need to know how much flash or how much fast share you need to use in your storage array. And of course, what we also want to do is help PernixData and help the architect for you guys to eliminate troubleshooting headaches. So it's a very intuitive interface to use. So you might have some users complaining about performance, and you know you have to look into this. But you have all of these tools. You can go to vCenter graphs. You can go to your storage arrays graphs. You maybe have realized operations. You have so many tools that you can all over the place you can look into. But we are really focused on the user experience of this troubleshooting. So it's not about just showing you guys counters and graphs. It's about making it intuitive for you to go to the root cause in an easy way. So don't give them everything, but give people what they need to see. Maybe most times when you're troubleshooting, you don't know what you need to see. So we find the stuff you need to see. Let the software take care of it. The PernixData Architect software, how do you install it? How do you get started with it? It's running inside the kernel of VMware ESXi. So to get Architect and to start monitoring your VMs, it has to be in the kernel. The way to get it in the kernel is use Update Manager, or if you don't want to use Update Manager because you prefer command line, well then you put a host in maintenance mode, install the agent with a simple ESX CLI command, and then you exit maintenance mode. We don't even require you to reboot your host. We just want our agent inside the kernel so we can now see the I/O that is going on. Because the Architect software is getting the data to get the working set sizes, to get the block sizes, to get all of these data points. We need to collect the data ourselves. Because if we connect to vCenter server, we don't get the data we need from vCenter server. And even though you collect all the vCenter server metrics, then you don't know the block sizes. You don't know the active working set sizes. You don't know the stuff that is really, really important, because the vCenter metrics is not really built for this kind of granularity. So step one, get your own data, own the data, and then analyze it and bring it back to you guys as architects. So we take all of this data, bring it into our data system analytics system, and then we bring it back with VM Intelligence into an easy-use Architect user console that you can access. So you go to the console, and from this console now, you can start to design your storage when you need to expand it. You can start to operate your storage, and you can also use it to optimize your storage, because the data center is dynamic. It's changing every day. If you want Architect this week, well, in 2 weeks' time, something else is going on. And that is when you're designing storage today, and when you're building new storage, then you design for what you had. And then you say, so this is what we think we have. Using a lot of thumb rules and a lot of best practices, you get a storage. Then 6 months later, what you design for is not what is going on in your environment today. So how do we keep in the circle of not only designing and then forgetting about it, but going into a situation where we do this all the time, where we all the time design, operate, optimize, and get the data points we need to be successful with this. Predictive analytics, ensure proper storage sizing. How do we design? I don't know if anyone have ever been using something like this when you're designing storage for virtual machines or applications, where you have to define, oh, this database its workload is kind of like OLTP, I think. And then you put OLTP in it. And then you put in some other numbers you think about, and you, by best guesses, you figure out, like, this is what I think my VM is doing. And then the vendor tool will say, okay, when you fill up this is what you need. And if you're very, very lucky, it's true. Because if you're very lucky, then you got all of the right parameters. But for the architect, it's not about using these kinds of tools anymore. The architect sitting inside the kernel, seeing all IOs, it will give you stuff like working set sizes. It will give you the information you need to be successful with storage. So guys, open question. What are some of the parameters you need when you're designing new storage? What are some of the things we need to understand before, when we are looking into doing some changes in our storage infrastructure? Anyone? Anyone? Could stuff like the read-write mix be important? Like how big of a percentage is reads, how big of a percentage is writes? I think that could be important to figure out, like, is it read heavy, or is it write heavy? What is going on? And not only that, but also looking into stuff like, one thing is just the percentage, but also how many IOs do I need? How many IOs are my virtual machines issuing today? But what's also important for designing storage, stuff like the block size distribution of IOs. So from a per VM level, being able to see on a per VM level, what are the read block sizes for this VM? What is the write block sizes of the VM? To have this information as well when you put this into the context of designing storage. And even looking at the working set size or the hot data of your virtual machines and your applications. So maybe you have 20 terabyte of data, but how much is hot? This could be anything from 1 terabyte to 20 terabyte. When you talk to most storage vendors, then they say 10% is hot. So 2 terabyte is hot because you have 20 terabyte. But it's just like a thumb rule. Let's try to understand this. Let's try to measure this and now deploy storage from what we have learned and what we have seen. We'll do the demo of the architect, some small screenshots. Let's get back to that later. But what Architect is also doing, helping you guys to design, giving you all the right information you need to be successful with that. Architect will also help you optimize your storage and make sure that your storage is always running as it should. So we have a proactive recommendation engine. And you can see some of the recommendation we do in this environment telling us, whoa, you have some VM that is doing overlapping IOs. We have some VM that are doing large IO sizes. Large IOs can be bad for the network. You can run out of bandwidth. So by getting this information, now you can act on it. You can now find the noisy neighbor. You can find the VMs that are misbehaving, and that is pretty much maybe bringing all the other VMs down. So from a large IO size, what do you do? Where do you go from that? When you click it, and then we give you some recommendation on how to act on this. One way to do it is, of course, we'll talk about later, is use PernixData with RAM to accelerate it, because RAM does not care about block sizes. Flash does. At the same time, we see some policies that these VMs should be in write policy, and these should be in write back policy. So if you're using PernixData Architect with our FTP software, we will even tell you guys how to use and how to accelerate your VMs with the FTP software. So recommendations are like, some are like for FTP, but most of the recommendations are like for storage in general, and are something that are related to the VMs and that will work that is meaningful in any storage environment. So most people today with storage, they're right here. They're deploying storage. Think about it, deploying storage. 6 months later, 12 months later, deploying storage. But with the Architect software, we want you to be able to actually deploy. We want to like go the full circle. So now you can deploy storage, you can monitor it, and you can optimize it with our recommendation engine. And once you need more capacity or you need more IOs to get better performance, well then now you got the data points to actually design it and deploy more storage. So it's about knowing the full circle. So Architect, it's not a monitoring solution. So a common question we get, oh, I'm using vRealize Operation Manager. I'm using VM Turbo. I'm using SolarWinds. I have a monitoring solution, but that's not the point of PernixData Architect. PernixData Architect is a tool built for the data center architect to help the architect his data center. It's not a tool to show on a screen if a data store is disconnected or connected. That's not interesting. It's not an interesting challenge to try to solve. If something is connected, you have those tools already. But I don't think you have the architect. So with the architect, we will make you love your SAN again, because now you get the per VM storage visibility. Even though it's on a shared storage array, you get the per VM storage visibility. So that's one thing you need. But another thing you need, and you're probably thinking about, is you also need fast storage. So some of you have very fast storage, some of you have slower storage, and medium storage. Can PernixData, how do you fix that? Well, with the PernixData FTP software, so now before Architect, now we're going to talk FTP. So with the PernixData FTP software that is installed in the kernel, it's the same kernel module as the Architect software, so it's only one piece of software. It's only a license question. Once we have the architect and the host, then PernixData will let you use RAM SSD or PCI Express flash locally in the host as a read and write acceleration cache in front of any shared storage. So now it doesn't matter how fast your storage is, because now your virtual machines will start to experience the performance of RAM, or the performance of SSD, or the performance of maybe NVMe PCI Express flash. And that is how we can make you guys love your SAN again, without doing any changes to the SAN at all, without doing any changes to the VM. So it's important to say PernixData is not removing the SAN. So we're not like saying SAN is bad, no SAN, goodbye SAN huggers, and all that stuff, right? We're saying SAN is a perfect place to put your data. It's safe, you know it, it's trusted. When you need more capacity, you can add more capacity to it. We just say we can solve the performance issue of a SAN by using these high-speed devices as a read and write acceleration locally in the host. And talking about performance, and talking about using flash or RAM in the data center, it's all about location. How do I get the best performance in my data center? You have to think about location. You have to think about, where do I put my flash? So looking at this picture, is this a good location for a donut shop? Or is it a bad location? What do you think? It's good location. And why is it good location? Yeah, exactly. So it's close to your customers, right? So the customers, it's easy for the customers to get to the donut, because the donut is right next to the police station. And that is definitely a good location for donut. But let's change the mindset about this, and let's not talk about donuts. Even we could spend a lot of time talking about donuts. But let's talk about flash in the data center. Where do you put the flash in your data center? Where is the optimal use for flash? So if we look an ESXi host with a VM running an ESXi at the top. At the bottom, we have the storage array. To go from the VM all the way down to a disk in an array, you have more than 12 queues you have to pass. So there's a lot of spinning parts all the way from a VM down to a disk in the array. And the traditional storage vendor, where will he put his flash? He only has one way to put it, right? He puts it in the box, in the storage array. But with PernixData software, and this is what we want to try to do with you guys, that is, let's say, hey, let's think about this. If we have some very clever software inside the kernel that will transparently let us use flash without removing the array, that basically means we can put the flash all the way up into the host to get the lower latency. So you could put the same flash device in the storage array as you put in the array, as you put in the host. The same flash device will now perform better because it's closer. So this is the donut that is right next to the police station right now. Doing what at the bottom? That is like, let's say you want to rob a bank in New York, and then you park your getaway car in Los Angeles. That is what the storage vendor is doing, putting the flash far away from the application, but that's the only way they can place it, because that is their box, that is where they work. Some of you guys think, okay, flash is cool, but I need better performance than flash. Well, I will help you with that as well. We don't necessarily require to use SSD or NVMe flash. We can even use RAM that is already inside the ESXi server. So if you want even lower latency and even better performance and more IOs, well, if you want to use RAM and you have some RAM in spare that is not used by your virtual machines, well, then go ahead and use it for the FTP software to accelerate the IOs. So in general, the thing is that virtualization breaks storage performance, because all of these random I/O patterns from all of the VMs goes into the network, goes to the storage array, and it's all just one big random. It's like the blender effect. All IOs is just random seen from the storage array. But with the FTP software, what we do is we decouple the performance from the array. We don't remove the array. That's so important to remember this. Like, this is the I love SAN session. This is not the no SAN session, because we work in front of the array. We don't remove the array. So you still get your capacity. When you need more capacity, you get it from the array. When you need your data services, you get your array. But now you can get the performance right very close to the VM to get the lowest possible latency. So you're thinking, okay, Wayne, this software, it really promises a lot. It must be extremely complicated to install and configure. Well, the PernixData software is installed in the kernel of ESXi. It's a supported and trusted module by VMware, so it's on the supported vendor list from VMware. Installation in a host is as little as 2 minutes. Put the host in maintenance mode, install the extension, exit maintenance mode. You're good to go. Once you have it installed in the kernel, then we will let you use RAM or SSD for acceleration. When we do this, because we're in the kernel and we're sitting in the I/O path, there's no changes to your virtual machines. So we don't install agents, drivers, anything in your VMs. Perfect. And also, we are transparent to your storage. So we don't change your storage. We're not creating new data stores. We're not doing anything new about your data stores. So it's kind of like, if you want to try it out, you can go to our website and download it, install in 5 minutes, and then now you can experience the performance of RAM instead of the performance of shared storage. That's a 5 minutes operation. And you can download it from our website. And you can see it for yourself if you don't believe me. But be careful if you download it, because this stuff will be very impressive. Because it's in the kernel, it also means who can use this software. Well, it doesn't matter what kind of server window you're running, as long as it's something that is running VMware. What kind of flash RAM can I use? Well, you can use any flash RAM that physically works with your physical server. And of course, that works with a VMware server. So our hardware compatibility list is pretty much the VMware hardware compatibility list. And what kind of storage can you use? Well, it will work in front of fiber channel over Ethernet, iSCSI, NFS. So you're kind of like, it doesn't matter what vendor name is on the box. What matters is that it's a data store for VMware and the protocol, NFS, iSCSI, fiber channel. That is your opportunity. Then you think, there gotta be a gotcha, right? You're waiting for it. Where's the but? You think, but what about vMotion? High availability. I need stuff like vMotion, HA. That's really important for me. PernixData works in the cluster level in vCenter. So you have 2 hosts in a cluster, or 10 or 20, it doesn't matter. You put PernixData on the 2 hosts in the cluster. So even stuff like vMotion, once you do if DS does a vMotion or you do it manually, we will still be able to read the hot data over the network. So the network we use for this out of the box is the vMotion network. If you don't want to use the vMotion network because you want a dedicated network, we'll create a VM kernel and call it PernixData. In our software, go to a drop-down menu and say, don't use vMotion, but use the PernixData VM kernel for this kind of traffic after vMotion. So it's a normal network you're using to access this data. So vMotion works, DS works, VMware high availability works if the host is crashes. And what I should also say is that PernixData FTP, it will accelerate the reads, but it will also accelerate the writes. So it's full read and write acceleration of IOs. And the writes are fault-tolerant accelerated. Because what we can do when a VM is writing data is, we can write it to the local SSD. And then we define a policy that you want 1 or 2 extra copies. So write it locally, but also send it to 1 or 2 other hosts in the cluster. So if a host crashes or SSD dies, it doesn't matter, because the write data was replicated to 1 or 2 other places in the cluster. And those other places then can continue destaging the data to the array where it's safe. So this is not only read, this is read and write. Most of the PernixData customers, I think the most used application for PernixData for acceleration, that is SQL Server, MS SQL, Oracle Server. That is the most used application that people accelerate with SSD or RAM in front of the storage array. Then you say, why are they doing this? Well, often the database servers are very important for the business. And other times when it's important for the business, it's also important for the users and having a good user experience. And because of our fault-tolerant write nature, we will fix the read and the write problem. Fault-tolerant, even for SQL servers. So with PernixData, you put the PernixData inside, you put the PernixData software, FTP software, and the architect software into your host. And when it's in your host, now you have a true scale-out storage performance platform. Because whenever you are going to add more hosts to your environment, well, add host number 4. with a local 200,000 I/O flash device. Well, now you got 200,000 more I/Os. Add host number 6. Now you got 200,000 more I/Os. So now your host is not only scaling on CPU and memory, but it's also scaling on storage performance and I/Os. The capacity is still something that we're getting from the array, but the performance is now scaling. So what kind of applications are PernixData accelerating today? SQL, general infrastructure, web apps, Exchange, SharePoint, VDI, other databases. So this is just like some of the things we are doing. And to be honest, we are mostly doing MS SQL and Oracle. So it's not like the low-hanging fruit and let's use this software for something we don't really care about. We are accelerating the real stuff. We are accelerating the important business applications at our customers' environments. And back to the point of scale. Put PernixData on there, new host, scale, new host, scale. And some of you are thinking, so what does this look like? You want a demo as well, or more PowerPoint? Okay. So PernixData software supports vSphere 5.0, 5.1, 5.5, 6.0. So it doesn't matter. If you're learning 4.1, sorry, I can't help you. Then you have other problems. The way PernixData is implemented in the vSphere client or the web client. So if you prefer the web client and you have good time and long coffee breaks, then go by the web client. I will do the demo in this client. So what we do once PernixData is installed is we have this very simple cluster, 2 hosts, 3 VMs. Then we can go to the PernixData tab in the vSphere client, and then we can click this link to open up our management server. So it's outside the vSphere client, but we still show us inside the client. You want to accelerate VMs? Well, you do that. So what do you want to do? You want to use RAM or SSD for acceleration? What do you think? Anyone? You want to use both? Okay, we'll do that. So you want to have both. Okay, so what we do is we create a cluster and call it both or mixed or 3000 par or EMC times 1000. You can give it a lot of funny names. And what you do once you have created your cluster, then you go to the cluster and you add some acceleration resources to this cluster. So an acceleration resource from a ESXi host can either be a local SSD device that is local in the host, or it's RAM. So let's do this. From one host, I'm going to add 400 gigabyte of SSD, and from the other host, I'm going to add, let me just think about it, how much RAM am I going to add? Well, you decide. As long as it's free, as long as it's not something that has been taken by the VM. So I'm going to take 4 gigabyte of RAM from one host and 400 gigabyte SSD. Then I'm going to click OK. So now on my VMware environment, I have an acceleration cluster. And now I can start accelerating VMs. What you will probably notice is that you have some VMs that are very latency dependent and would take good use of SSD and RAM for acceleration. And you have other VMs you don't really care about because your application owners, if this VM is slow, it doesn't matter because the application behavior is not reliant on good performance from the storage. So we let you do it on a data store level or VM level. Go in, find the VM, VM17, accelerate it. Okay, perfect. Is it write through? Read caching. Is it write back? Read and write caching. And when you do write caching, then you think redundancy, no single point of failure. So let's just say that we want to have write back with run security copy. Done, okay. And now my VM is in write back mode with one security copy. And it's even more crazy that on the one host it's using SSD, on the other host it's using RAM. But the PernixData software does not care about what kind of SSD you're using. It does not care about RAM. It just cares about that there's some acceleration media we can use. I'm not saying this is the best design doing these mixed clusters. Maybe you want predictable performance using the same in the host, like maybe using SSD all over or using RAM all over. That is what you can do. So that is how you use the FEP software to accelerate your IOs. And let me just see if I can get the last part of the demo running. So that was the FEP software. So FEP software is used for accelerate IOs. But our newest software called the Architect, that is a software you use to architect your data center and understand your application behavior and understand what is going on. So because we can see all IOs, then we can take this data and bring it back to you. We only have a few minutes left. So I'll just show some of the cool stuff in here. For instance, we can go to intelligence, we can go to the working set. So now I can see my active hot data for every VM in my environment. Now it's not guesswork anymore. Now I know, so these are actually my VMs that are touching a lot of the data, and how much data are they touching? Why is this important? Well, one thing is, if you're going to use FVP, you will ask me, or everybody will ask me the question, how much RAM or SSD do I need for acceleration? Well, since we now know the active working set, then we can do in the insight and the acceleration resource sizing, we can tell you, in your environment, this is the amount of SSD or RAM you need to use to have the best performance in your environment. So removing the guesswork, doing stuff from facts, not doing stuff from thumb rules, 10% rules, or gut feelings, or I think, last time we did this. So getting this information right in there. And not only that, and this is also something that is very clever, is that in this case, we see my storage. We see my data store, the purple line. My data store is all over the place. At this point of time, my data store did 47 millisecond latency. But the VM observed because of the PernixData acceleration was 1.7 millisecond at this very specific time. So this is kind of like the perfect picture of what PernixData is trying to achieve in your customer's environment. You're going from the purple line, so the VM are experiencing this performance instead of this performance. That is what we do in front of any storage array. And that is how you're going to love your storage array. Even better, last thing, when you see something in the graph, now these graphs are not graphs anymore. They are interactive. So you see something in the graph, there's a peak. What does that mean? You click it. Well, then we give you the data that makes sense in that, to correlate the data to the incident. You see a latency peak. We think you want to see the highest 10 VMs with latency at that point of time. Because maybe you have 500 VMs, maybe you have 50 VMs. So now we will show you and break it down. So the graphs are something you can, if you see something, you click it, you work with it. And looking at latency, latency is not only about the latency anymore. Now we will do latency, and we break down latency all the way down to block sizes. So now you can find these VMs that are issuing large block size IOs, and you can fix it. Because in the user interface, and tell me where today you can find per VM block size visibility for IOs. That doesn't exist. Now you can do it in front of any shared storage with the architect, and you can use the architect to architect the perfect data center. And that was, I think, with 1 minute left, that was my finish, my end.